Hey guys, Travis Gillespie. In the last video, you learned how to identify lines that are perpendicular. They have a product that their slopes have a product that's equal to -1, or you have a vertical line that's intersected by a horizontal line. So let's move down and actually look at a graph of a triangle or any shape and determine how do you determine if lines are perpendicular based off the shape and you're not given an equation such as in slope-intercept form. Well, what you're going to end up doing is let's actually look at this shape first of all and say, do any of these lines actually look like they create right angles? And, if you look along, that point C, there's no right angle here. It just doesn't look like it. And also here, but it actually looks like I could eyeball this and say it looks like line segment BC and line segment AB, those two create right angles, possibly, but I can't guarantee it yet. So what I've got to do is just like when using finding out the points for parallel lines, shape of parallelogram, you're going to find the slope for lines that are perpendicular. All you're trying to do is find the slope of the lines that are either intersecting or look to be parallel in case of identifying parallel lines. Well, let's look for we're not going to look at AC at all because it doesn't look like it forms any right angles, but let's look at line segment AB and also the slope of line segment BC. Let's figure out what these guys end up creating here. I'm going to change the size of and I'm just going to plug in my x sub 2. Let's call B my honorary x sub 2 and y sub 2 points. Cool. So for AB, my y sub 1 and x sub 1 here, I'm going to be able to plug in some points now for my slope formula, and I know that, well, y sub 1 y sub 2 is going to be -2 minus, I'm going to look at AB, so y sub 1 is going to be -1. -1 over, I look over here, I've got x sub 2, and that's going to be -2 minus, and look at +2. And now let's go ahead, I'm going to go ahead and just plug in the values for the other formula as well. I'm going to look at line segment BC here and say, well, my sub 2 values, they're going to again be, well, -2 minus +2 over -2 minus -3. Cool. So from here, I can go ahead and start solving these problems. And I'm going to start with line segment AB. And I know that my slope here, it's going to be -2 minus -1. Well, that's really adding. So -2 plus 1 is going to give me -1 over -2 minus 2, -4. So I've got really 1/4 here. And that's my slope. Let's move on to the other, -2 minus 2. That's going to give me, well, it looks like I've got a 4 here, -2 minus 2, and the -2 minus -3, which is really going to give me -2 plus 3. So -2 plus 3 is going to give me 1 here. -2 plus 3 is going to give me +1, which is going to give me -4 over 1. And right now I see that these two slopes, that one of them is the reciprocal to the other, but a negative value in front of it. So it's the opposite reciprocal of 1/4 here. So if I take the products, I already know they're opposite reciprocals, but now I'm going to take the products just to show you how it's done and say that, well, 1/4 times -4 over 1. These are supposed to be parentheses here. I'm going to go and undo it and just say, well, the product of these guys actually equal -1. So these guys are perpendicular, and I proved it here by finding the slope first and then taking the product of their slopes and finding out that the product of their slopes equaled -1. These are perpendicular lines. Cool stuff. I'll see you in the next video.